Hi everyone, it's Coach Fred here, and today we're on video for cost, income, and value problems. But to get started, I want to go over just turning the idea of cost, income, and total value into a mini formula or a formula that we can use. I'm hoping that, if I want to find the cost of something, then I would take the number of items I have, and I would multiply that by the price per item. So if I have 10 apples and their apples are 75 cents, I would multiply 10 times 75. All right, so we can write that as a formula. We could say that the cost is equal to the number of items times the price. Noticing we're just taking two things and multiplying them. Similar for income. If I'm trying to find the income I make for an hourly wage, I would take the number of hours worked, and I would multiply that by your wage per hour, how much you make per hour. And I could write that as a formula. My income is equal to the number of hours worked times, say, our wage. All right, and the last one, all of these are pretty similar, is total value of something. So if I take the number of items I have and I multiply it times the value per item, similar to cost, it's going to give me the total value. So like T equals N times V. Now I want you to really think about these. These are all formulas where I'm multiplying two things. They're very similar to finding like the area, the length times the width. So we're just multiplying. All right, we may need these for this next piece of the puzzle. So today what we're going to look at is how to write an equation using cost, income, and value, and also using a total number. So here's a good example. Now we're going to still write things with one variable. I'm going to introduce two variables to you this week, but I want to make sure we can do with one. Tickets for the senior class play cost $6 for adults and $3 for students. A total of 846 tickets worth $384.46 were sold. How many student tickets were sold? All right, so that's my question. So I'm going to let S equal the number of student tickets sold. Okay, now if there's a total of 846, that means that 846 minus S is equal to the number of adult tickets sold. Because if I take 846 and I subtract the number of student tickets, I'm going to be left with the number of adult tickets. All right, now everything else is going to be based on the cost, okay? So the number of student tickets times the cost of those tickets, so 3 times S, plus $6 times the number of adult tickets, so 846 minus S, has to equal my total cost, so 3,846. All right, so now I solve that equation. So 3S, I'm going to distribute the 6. That's going to give me, 5,076 minus 6S equals 3,846. Oops, wrote 4. All right. Then we just use our algebra. We simplify each expression, and then we balance the equation. So we get negative 3S plus 5076 equals 3,846. I'm going to subtract 5,076. And that's going to give me negative 3S equals, negative 1230. So S equals 410. I go back to the question I was asked, how many student tickets were sold? I'm done. So 410 tickets. I'm going to box my answer. All right, so the only new piece we added to this was number 1, finding the second variable in terms of the total, which was this, and then having to multiply each of the number of items by the cost to write an equation. All right, let's try it with income. Marley makes $5 an hour working after school and $6 an hour working on Saturdays. Last week, she made $64.50 by working a total of 12 hours. How many hours did she work on Saturday? Okay, so we're going to let S equal the number of hours she worked on Saturday. Okay, now my other variable relates to what her hours working after school. So we're going to, and there was a total of 12 hours that she worked. So we're going to let 12 minus S equal the number of hours she worked after school. After school. All right, now we've got to talk about her income. So she worked S hours on Saturday and she made $6 an hour, so that would be 6S. And then after school, she made $5, so that would be 5 times 12 minus S. That's going to give me her income. Her total income with those two things together was $64.50. So that's going to equal $64.50. And then I just solved the equation. So let's see what we get here. 6S plus 60 minus 5S. We distribute that 5. We combine the like terms on each side, so we're going to get S plus 60 equals 64.50. Subtract 60, and I'm going to get S equals 4.5. So how many hours did she work on Saturday? She worked 4.5 hours. Hopefully this is all coming together for you. All right, the last one we want to talk about is our value. So these are very common questions. A collection of 40 dimes and nickels is worth $2.90. How many nickels are there? So yes, I'm going to start with my let statement. We're going to let n equal the number of nickels. And we're going to let 40 minus n equal the number of dimes. All right. So think about this now. If I want their value, I actually need to know the value of a dime and a nickel. It's not given to me in the sentence. Well, a dime is 5 cents, a nickel is 10 cents. So I could write this like this. I could write 5 times the number of nickels plus 10 times the number of dimes equals 290. But Coach Fred, where'd the decimal go? Well, I decided that I didn't really want to use the decimal. So I knew that if I wrote it with decimals, I would have 0.5, 0.10, and 2.9. And there were 2 decimal places I wanted to get rid of, right? So if I wrote it without the decimal, I just had to consider those decimal points, me moving them. So that's why I wrote it like that. But I had to get rid of them in the 290. Otherwise, the 2.90. Otherwise, I wouldn't get the right answer, okay? Because they have to be in the same units. All right, so I'm going to distribute, and I'm going to get 5n plus 400 minus 10n equals 290. So negative 5n equals, what is that, 110? Negative 110. And so n equals 22. So how many nickels are there? There are 22 nickels. Now, some of you might be saying, Coach Red, I think you could have written these equations as a system. Now, you certainly can. So I'm actually going to take a minute here to show you how this could be done using a system of equations. Okay, so I'm going to actually write it parallel to it. If we were going to write this as a system, we would then first have our variables. We would let n equal the number of nickels. And we would let d equal the number of dimes. But we'd have to write 2 equations. So our first equation would have to be related to the total number of items I have. N plus d equals 40. And our second equation would relate to the value of those items. So 5n plus 10d equals 290. Now, you could either use substitution or elimination to solve. Now, if you use substitution and solve for d, we're going to get 40 minus n. Look what happens when I plug that in right there. You end up with 5n plus 10 times 40 minus n equals 290. So that's one of the reasons I like using one variable, right? you're doing kind of extra work. Now, if you didn't, you might not have seen that though if you were using elimination. If you used elimination, let me go through that. If you were using elimination, you'd want to eliminate one variable. And so in this case, I'd actually have to multiply the top equation by a -5. And I would change my equation. I'd kind of make it bigger. I'd be getting -5n minus 5d equals -200. Okay, then you add the equations together. The reason I multiplied the top y by -5 is I wanted this variable to have the same coefficient but opposite signs, so that when I simplify, when I add them, the opposites go to 0. So these get eliminated, and I get 5d equals 90, divide by 5, and so d equals, what is that, 18? And so if d equals 18, then n would have to equal 22. All right, so that's how I would do this if I were using two variables. But for now, we are going to use one variable, but I wanted you to see it. So when we get into two variable equations, this seems a little bit easier for you. All right, guys, have a great day.